When we picture the heart, we usually think of it as this one giant, powerful pump, right? But today, we're going to zoom in on a real unsung hero, the right ventricle. This is the chamber with one super critical mission: to fuel your lungs. So let me ask you something. What actually powers every single breath you take? Really think about that. We hear all the time about the heart pumping blood to the body, but what about the lungs? What's the engine that kicks off that whole process of getting oxygen? Well, you guessed it. It's the very chamber we're taking a tour of today. All right, let's dive right into its main job. There's a really good reason we're calling this the lungs powerhouse. Its whole design, its entire purpose, is built around one single vital mission.
And here it is, plain and simple. The right ventricle's job is to take all that used, deoxygenated blood, the stuff that's just come back from its trip all around your body, and give it one big shove. And its destination? You got it, straight to the lungs, so it can get re-energized with a fresh supply of oxygen.
Okay, now this is where it gets really cool. Look at how perfectly this thing is designed for its specific job. The wall of the right ventricle is way thinner than the left one. And you might ask, why? Well, it's because it's only pumping blood right next door to the lungs. That's a short, pretty low-pressure trip. The left ventricle, though, that's a different story. It needs that super thick, muscular wall to generate enough force to blast blood all the way to your brain and down to your toes. It's just a perfect example of form following function. So, we know the ventricle is ready to do its job. But how does the blood even get in there in the first place? Let's trace the path it takes to get inside. It's actually a beautifully simple and efficient little system. First, blood gathers up in the chamber right above it, which is called the right atrium. Then, when the heart muscle relaxes for a moment, this little one-way door, the tricuspid valve, swings open and whoosh, the blood just flows right down, filling up the right ventricle and getting it all loaded up for the big push. All right, the chamber's full. Let's peek inside. You might be picturing, a smooth, simple container, right? But the reality is way more interesting. It's this incredible landscape of muscle and architecture, and every single piece has a critical role to play. And this internal setup is basically an amazing safety system. First, you've got these muscular ridges lining the walls. They're called trabeculae carneae. Then, attached to those, you have what are called papillary muscles. Think of them like little winches. And those winches are pulling on these tough, fibrous cords, the chordae tendineae. The whole setup, all three parts working together, has one job: to yank that entry valve shut when the ventricle contracts so that no blood leaks backward. It's brilliant. Okay, so the chamber is full, the entry door is sealed shut. It is time for the main event. Let's follow the blood as it makes its grand